This is our Harman control panel for the P-series stoves. It's located on the right-hand side of the stove, facing the front. And this control is used in, well, it used to be used in all of their stoves. Some stoves have been adapted to use the touch control. The P-series is not. And this is the layout. We have a few knobs and a few switches and a few indicator lights. And right now, the stove is not plugged in because the power light is not illuminated. If the stove is plugged in and this power light is not lit up, then the fuse inside this control board has gone bad, and we're going to want to remove this and change the fuse. When you plug in the stove, the combustion blower comes on for 2 seconds. If you plug in the stove and immediately the power light goes out, your combustion motor is going to be bad because it's going to be drawing too many amps, and it's going to be blowing the fuse behind this panel. So if you put a new fuse in and you plug it in and you turn it on and then your power light goes out, replace the combustion blower. That's going to be the thing that is drawing too much current when you plug the stove in. If you blow a fuse as soon as you plug it in, it's always the combustion blower because it's the only thing that is getting power. If you plug in the stove and your combustion blower comes on and it won't turn off, it's going to be because the air switch is not closing for whatever reason, and you're going to have to figure out what that is. Or if you go to shut your stove down and the fire dies, but the combustion blower just keeps running and running and running and won't turn off, you have to figure out where you're getting an air leak, because the combustion blower is reading that the airflow switch is reading that it's not closed. Either that, the stove still has more than 95 degrees of heat inside of it. When the stove reaches 95 degrees, as determined by the ESP probe, the combustion blower turns itself off as long as the airflow switch is in the closed position. The first thing that we have is a feed limit. The feed limit is the percentage of feed that the stove is going to be engaged in when it's feeding. The number 4 is where Harman recommends that you run the feed limit all the time. If you have a pellet that is really stubborn and doesn't produce much heat or very high flame, you can increase the feed limit. If you have a pellet that is very combustible with a really big flame, you can retard the feed limit. But always start from 4 and see where that puts you. That's usually good. Some pellets I'll bring it down to 3. Some really nice Douglas fir pellets, I'll even bring it down to 2. But for the most part, you're going to stay at 4 pretty much all of the time. And the way that you can check this is that you turn the stove on and you let it burn on high for an hour on the number 4. And in the burn pot, you should have 1 inch of ash in front of the coals. If you have more than 1 inch of ash, turn down your feed limit by 1. If you don't have 1 inch of ash in front of it, you would turn it up by 1. However, if you're using a pellet that does not have very much ash to begin with, like Douglas fir pellets, that whole scenario is not going to work for you. So you can judge a Douglas fir pellet by its flame height, but I can tell you, if you're using really good Douglas fir pellets, turn your feed rate down to 3. You might even want to go down to 2. It really just depends upon how hot you're burning it. All right, the other thing that we want to look at is our igniter toggle switch. Right now, the igniter is in the auto position. That means that when the stove is turned on, the igniter is going to get power. If we disable the igniter, that's what this whole thing is all about. In this position, when we turn the stove on, the igniter is not going to get any power at all. And there's a reason why you might want to do that. If you're running the stove on a backup battery, your stove is not going to be able to light itself using the igniter because it draws too much power. In that instance, you would disable the igniter and you would start the fire on your own. Once the stove gets up to a running temperature, like 194 degrees or so, all of your other components will automatically come on. Under normal operation, if we have the igniter in auto, right, and the igniter is going to turn on at startup, we're going to turn it to room temp. Combustion blower is going to come on, and then our feed motor is going to come on, and then our igniter is going to come on. And it's going to run for about 2 minutes, bringing pellets into the burn pot. The heat is going to ignite them. It's going to build a fire, and when it gets to 194-ish degrees, the igniter power is going to be cut, and then the distribution blower is going to receive power, and the stove will be in run mode. If you are using the room temperature, which we have it in room temp, and we say we set it for 60 degrees, or 70 degrees, sorry. When we achieve 70 degrees, the stove is going to oscillate down, in which case it's going to shut down, turn itself off, but because we have the auto igniter on, when there is a call for heat again, all of this will come back on and the igniter will have power and it will be able to light the stove again. If we have the igniter disabled and we have it on room temperature and we're looking for 70 degrees, alright, we have to start the fire ourselves because the igniter is not getting any power. That's fine, we can do that. So we manually start the fire, everything gets up to where we want it to be, the feed motor will come on, and then the distribution blower will come on. But when we achieve 70 degrees again, the stove is not going to turn itself off. It's just going to go down to a low and it's going to stay there. And the reason why it's not going to turn itself off is because it knows that it will not be able to reignite itself. Alright, so when we have the igniter disabled, we're manually starting the fire ourselves, and the stove is not turning itself off when the call for heat is reached when you're using room temperature. Alright, and if we put this back to auto, then we'll turn it back off. Which brings us down to this knob right here. This is our off position. This is room temperature mode. This is the off position. And this is constant burn mode. And this is back to off again. On room temperature mode, we are looking for a desired temperature. Right now we have it set for 50. It's warmer than that in here, so the stove didn't start up. But as we increase the demand, the stove will now start up, achieve fire, and maintain a pretty high burn until we get to roughly about 72 degrees. And it's going to oscillate itself down at that point in time. When it achieves the demand, it's going to oscillate down for about 35 minutes. And if it does not receive a call for heat within that 35 minute of oscillation time, the stove is going to turn itself off, and it's going to remain in this state until the call for heat comes back again. Obviously, we wouldn't have to turn that knob, it would all be done automatically. If we use the constant burn mode, using the numbers on the inside of this dial, we have it set for number 1. 1 is trying to start up, achieve, and maintain 350 degrees in the exhaust measured by the ESP, the exhaust sensing probe. If we turn it up to number 7, it's going to start up and achieve and maintain a temperature of 498 degrees in the exhaust as measured by the exhaust sensing probe. And everything else is a variable in between those two temperatures. In constant burn mode, the stove does not oscillate up and down, it's constant. It just keeps it burning on whatever level you have until you physically come over and turn it off, or it runs out of pellets. And then this knob right here, which is our temperature or burn selector mode, goes from 50 to 90 degrees or from 1 to 7, as I just explained. If you're using room temperature, you're not using the 1 through 7. If you're using constant burn mode, you're not using the temperature degree on the outside. If you have it on constant burn and you have it set for 75 and you wonder why it's 88 degrees in your house, it's because it's not reading the room sensing probe that's on the back of the stove. And this is where it's measuring the temperature from when it's in room temperature mode. So if we set this to 80 degrees, it's looking for 80 wherever this thing is located. All right, and this attaches to the back of the stove, but if it's on a cold wall, your house is going to be really warm. If this is mounted somewhere where the sun can hit it, your house is going to be really cold. If this is on the floor where it's really cold, you're not really getting an accurate reading. This probe right here should be mounted about 3 feet off the floor on a non-exterior wall or somewhere where the air can circulate around it to kind of get a true reading of the temperature. You can buy an extension of this wire, and you can, extend this wire to about 35 feet away from the stove and put it wherever you want to. But this probe right here and this wire has to kind of go from the stove all the way to where this is going to reside. I've asked a lot, and they want to know, do I have to use this probe? Can I just use a thermostat? With this control board, the answer is yes, you can. You don't have to use this probe, all right? But you do have to use this probe in line with the thermostat wire. If we turn this thing on room temperature right now, and we don't have this attached, we're getting a status blink of number 4. 4 blinks. That means it's not detecting the resistor in the end of this. Where these two wires connect to the pigtail that goes to the board, you can actually install a thermostat to those terminals. And then on one leg of the thermostat, you have to put this resistor in line with it. And then just use the thermostat to open and close this circuit. And then you can use a thermostat, but you're not going to get this oscillation when you achieve temperature. It's not going to oscillate up and down. It's going to just cut and go to a 4 blink status as soon as your thermostat achieves the temperature. But it's not going to work at all if you don't have this guy in line with the circuit. All right, so make sure that this is in line with the circuit, and maybe I'll make another video about how to do that. But for the most part, just use this room temperature probe. It's actually very easy to use, and it works. It's remarkably accurate as long as this end of the probe is in the right location. If you put it on cold, your house is going to be really warm. If you put this somewhere where it can get warm, your house is going to be really cold. So just make sure that the temperature of the stove is not affecting this. Sunlight's not affecting it. Cold floors aren't affecting it. All right? And that one, that's that. Okay, so there is a hidden mode in this. Actually, there's 2 hidden modes in this. If you want the stove to run in a high-low mode and still use the room temperature function, all right, turn your stove on using the room temp mode, let the stove achieve fire, and as soon as you see fire, disable the igniter. Now the stove will oscillate up and down. Say we have it set for 75, it will burn on high until it gets to 75, and then it will burn on a low, but it won't actually turn itself off. When it calls for heat again, it will come back up to high and go back to 75. And it will continue to operate like that until you physically turn it off or it runs out of pellets. summer romance. Now, this is a way in which you could use the stove in a warmer temperature, like in the summertime, for the ambiance of fire, but not having the heat blowing out in your face. All right, and to do that mode, you're simply going to put it into, well, start it using the auto, and then once you have fire, you're going to disable it, disable the igniter, and then turn the mode down to constant burn mode, and make sure that this knob right here is below the number 5. So when it's disabled, igniter, constant burn, this knob will only give you a distribution fan. It will only blow the circulating fan when this knob is number 5, 6, or 7. If you turn this knob down to 3, it's going to turn off your distribution blower, and you're not going to get any heat blowing out into your face. And then to set everything back, simply go that way. And then the last thing that we want to show you about the board is going to be your room temp and constant burn in this sweep pattern that you have there. This is a multifunction knob. Not only does it switch between room temperature mode, off, and constant burn mode, but the amount that it turns from here to there, low and high, is your distribution blower or your room blower. So if you want to run the stove, with a fan that's barely running so you can't really hear it, you run it down low. If you want a quicker recovery and you want to heat the house up faster, you can give yourself more fan. And the same is true down on the constant burn mode. We can turn it down low, or we can turn the fan up to high. We can turn the mode off as well. Which is the best way to run it? If fans bother you and you don't want to listen to them, keep your fan on a low level. If you come home to a cold house and you want the house to be warmer really quick, give yourself a higher fan. If you want the most efficient way to run the stove for long periods of time, and you don't want the stove turning on and off and on and off, but you want to create a lot of heat, all right, run your stove in constant burn, keep your fan really low, and turn your feed rate up much higher. And that will allow the stove to get really hot, so you'll have lots of radiant heat from the stove. You'll still be circulating a little bit of air from this blower down here up and through the stove, but the air that comes out of the stove is going to be much hotter than if you were to turn it like that. A higher fan moves more air, but the air is not as hot as when you have it on low. And you don't have to have the fan spinning very fast to move large quantities of air. You just need to be able to move air through the heat exchanger. And that's how these older style control boards work. There is also a little knob right inside there that you can get with a small little eyeglass screwdriver. This is your combustion motor voltage trim, and it's set from the factory for where most installations will need it. If you have an installation that is higher in elevation, all right, above 4,000 feet, or you have a really long run of vent that produces a lot of extra draft, you can trim this down so that you're not moving so much air through the stove. But for the most part, that never really has to be messed with on any level whatsoever. And it's always set from the factory in kind of a 2 o'clock position, and it only turns to the counterclockwise. So right now it's wide open, and as we turn it counterclockwise, it's going to reduce the volts from 118 down to, I think, about 95 or something like that. But all intents and purpose, that is usually right where you want it, and just leave it there. Down here, there's an opening for a jack. This is for the Harman diagnostic tool. If you are a technician and you really want to get some more information out of it, you could buy a diagnostic tool to plug in there. Honestly, the diagnostic tool doesn't tell you much if you're just a homeowner, but it can help you really quickly solve some common problems with these stoves if you're a tech and you know what you're looking for.